Hello, guys. We're gonna be doing another live coding session. Well, live on Leetcode. I'm just gonna go through a couple of randomly selected medium Leetcode questions. So let's jump right into it. So the first problem is going to be number 739, daily temperatures. So let's jump into it. Given a list of daily temperatures in the letter T, return a list such that for each day in the input tells you how many days you would have to wait until a warmer weather. If there is no future day for which this is possible, put 0 instead. For example, given a list of temperatures 73, 74, 75, 71, 69, 72, 76, 73, your output should be 1, 1, 4, 2, 1, 1, 0, 0. The length of the temperatures will be the range, be in the range 1 to 30,000. Each temperature will be integer in the range 30 to 100. Okay, so what I'm immediately thinking about is that you can probably do this problem in quadratic time, or essentially O n squared time, because you could just loop through the pick the first index, and then for the rest of the array just iterate through that till you have reached a temperature higher than your particular current temperature, and then you just have like a temporary counter, and that resets after each new iteration. So your first loop, it's going to find that count, append it to this additional array that's going to be the output, and then after it's found that, then it's going to go to the next element in the first loop. Then the second or inner loop is just going to iterate through like a subsection of the rest of the overall array. So with space, I think it's going to be O and space, because as you're adding these counter variables, you're creating an additional array that's equal to the length of t. So I think we can do better than O n squared. So sometimes we can think about our O n log n time, or O n time. So first I'm just going to do a brute force quadratic time, and then maybe I'm going to try to use some use of clever indexing to do O n linear time. And actually I'm going to put a timer here. So Google stopwatch. Okay. Oops, wrong one. So let's do 17 minutes and 30 seconds. Okay, perfect. All right, so output, we're going to create that array we're going to append to. So for idx in range lang of t, then we'll just do -1, because in the inner loop in the inner loop we want to stop 1 before it, because we want the inner loop to go to that last element. Okay, so for jdx in range, and then you just do idx +1, and then the length of t, because it's going to be the last element. So, and then we're going to have a temporary count. Okay, actually with this, oh no, I can just append that number. Okay, so I don't have to, so what I was thinking I might have to do is initialize a length of the array equal to the length of t -1, but I don't have to do that, because if I just use the append function, it's gonna just add to the end of that array. So I don't have to do that at the start. So I just have an empty array here. Okay, so for this first element right here, that's the inner loop on this. I'm sorry, that's not the inner loop. This is the first element on this outer loop, and then in the inner loop, it's going to check the rest of these elements. And then once it finds an element greater than 73, then it's going to add that count or append it to output. So let's do this. Count equals 0. The start value is going to be t idx, and then for each one of these, you're going to actually do I have to do a count? No, I don't have to do a count because I can just do JDX minus IDX. Okay, so I don't need that count. If T JDX is greater than T start value, then what we do is, let's make sure, days until warmer. So days until warmer equals JDX minus IDX, and then we just append that to output days until warmer. Okay, so let me just walk through this. So so you have this index 0, this index 1. So if this is, let's just say that was equal, so 73, 73, so then we'll go to the next one. So we're at index 2 for JDX. So if this was greater than 73, 75 is greater than 73, then it's going to be JDX minus IDX, which is 2 minus 0, and that'd be the count there. So I think that works out. I don't have to keep track of an additional constant time variable and count. I can just cleverly use the indexing. So with that, so for that now, I just return output. Now let me just think about base cases. So there's at least going to be one element. So if T, len of T equals 1, then you just return 0. Let me just make sure. Okay, this looks good. So yeah, I'm just doing this base case, like looking at these notes right here. If it was empty, then I would just return an empty array too. But like, since we know that this range at least has 1, then we just gotta take care of that that single base case right here. All right, let's see if I missed anything. So for IDX, let's just say 73 right here. Set that to the value. So now start value, that variable has 73. Based on indexing from the T array with IDX, then you check the rest of this subarray right here in this inner loop. Okay, so the first element, so JDX equals 1. Why is it equal 1? Because it started this subarray with IDX 0 plus 1. Okay, and then it just keeps on iterating through that. So then T JDX equals 74. If 74 is greater than 73, days until warmer is JDX minus IDX, which in this case is 1 minus 0, and then you just append 1 towards that output array. So let me just make sure. Given a list of daily temperatures, return a list that for each day in the input tells how many days you would have to wait until warmer temperature. If there's no future day for which this is possible, put 0 instead. And now that I'm looking at it, like, what if there are no single elements greater than your current temperature at start value? Then that's when, so I actually do need that. I do need that external variable, because if you go through this whole subarray and there's no temperature greater than your current temperature, then you just want to add 0. So let me change that. So in this case, days until warmer, let's just do count equals days until warmer, break. Then from here, now you just want to do count. So why do we do this is, like, as soon as you meet your condition, which in this case, an element in your subarray is greater than your start value, then you just update the count variable. And if this never returns true, then you just append the count 0. But if it is true, you update count by the days until warmer, and then you just append that. And then at the next iteration, count's going to reset, so you don't have to do anything there. So I believe we have this right. Let's test it out. So again, if you have a lot of elements, okay, in this case, I was wrong about the indexing. So this is accepted. Let's see if we have any base cases. We might have time limit exceeded because we are using quadratic time. So in this case, yeah, we're probably gonna get like a time limit exceeded. So now we have to improve it to either, yeah, n log n time. Yeah, so we have a majority of these passed, but depending on how long this is, we're going to have to update it. But this is like one way you can solve it. So again, this solution right here, and let me just copy this. So all right, so this solution right here is O n squared time and O n space. Let me comment that out, and then let's try to make this faster. All right, so how can we make this faster? Could we use some type of hash map, some type of indexing to make this faster? So how do we avoid just looping through everything there? Let's see. So we do have to iterate through every element, right? So if my first element's 73, then we have nothing to add there. The last one's always going to be 0. So I think that's important to know. The last one's always going to be 0 because there's no element to the right that it can wait to. So 73, 74, so then you check the last value, right? Okay, so that's greater than you append by 1. Okay. Then 74, 75. Okay. Can we use a stack? Or a queue? Because what I'm thinking is, hey, whatever is the front element, wait till... Yeah, we could probably use one of those structures. So let's look at that. Stack or queue. So like what I'm thinking is, like, as you're iterating through this once, like just say, hey, 73 is an element, right? Okay, so then you're at 74. Is 74 greater? Okay, perfect. So if 74 is greater, then append by 1, pop this 73, then put 74. Hey, is 75 greater than 1? Okay, add by 1, and pop this 74. And then you gotta keep on doing that count. Okay. And then is 71 greater than 75? No, then you keep both. Then maybe you can use like the length of... Yeah, you could probably use like the length of the stack then. Okay. So 69 greater than 75 or 71? No. Okay. Then keep on going. 72, is that greater than 71, 69? Okay, so in that case you would pop like both. So from this you can say, hey, you pop that's 1. You pop this one, that's 2. Then you append those. No, but then it doesn't make sense because how do you keep track of 75? Very interesting. Okay. See how much time I have. Okay, I got 5 minutes. So would this queue work instead? No, because then, like, how would you get rid of the middle one. Okay. Would a hash map work? Yeah, let's see if a hash map will work. So 73. Then you initialize that to 0. 74 is 74 greater than 73. Yep. Okay, so you initialize that, get rid of that, plus 1, so you append that. Okay. And you use like a del statement to get rid of that. Okay. Then is 75 greater than that, so you just add whatever the value of its key. Okay. But then you still get into quadratic iteration. So like each time like you're checking, and there's no order in this either. Okay. So 1, 1. Okay, so now I'm focusing on these indexes. Is there a way that we can like check distance with this array, like in ON? I'm constantly thinking of this ON because I feel like there's a way for us to do this. Maybe we can use the max number in the array and then like go from there. So wherever the index is the max number. So for example, 73, 71, that exists, right? So then you can automatically like check based on like the indexing. Hey, yeah, that exists. So it's not 0. If it's not, then you can just do 0. So you can get rid of these immediately. I mean, like you can append those immediately. And then from there, so like this first element, 73, 76 is greater than that. So now wherever the index is, I think this is like 6 minus 0, so then you just iterate down. Is 72 greater? Is this is greater. So yeah, so this is greater, then that's 2, then you're just trying to minimize on that way back. But you're still using sub-indexing. And you're still iterating, you're just... Yeah, I'm still seeing some like quadratic iteration here. I'm gonna have to check this one later. This is a good one. Even though it exceeded time limit. Sorting wouldn't work either because you want to know like the placement of everything here. Maybe you could do like a ranking. So like, let's see. Let's do that right there. And then just see like where the next one is. So what I mean by that is from here, you wouldn't necessarily do like a sort, but okay, so this is the lowest item, right? So that'd be 1. Then it goes to 71, I believe. Yeah, 2. Then this goes to, 3. And this goes to, 4, 4, 5, 6, 7. Okay. So let's see if this this actually works out for this problem. Okay, so let's say we're at 4, then you try to find 5. Okay, 5 is there, so you just subtract these indexes here. Okay, so that would be, let's just do that, 1, 1. Then you just count that, so index of 7. So, oops. So index of 7, this would be, okay, 0, 1, 2, 3, 4, 5, 6. So 6, 0, 1, 2, 6, so that's 4. And then 2, then you go into 3, so that's 2. You go to 1. So that's behind you. Now you're just going forward. So that would be 1. Then you just go to 1, 0, 0. Again, you're kind of using some indexing, but yeah, I think that could work. You gotta do like some ranking, and then you just compare the difference, and if it's forward. Okay, I'll have to go back to this. All right, let's do a second one. So we did daily temperatures. Just make sure I X'd out of this. All right, let's start the next question. Target sum. You're given a list of non-negative integers, A1, A2, a target S. Now you have two symbols, plus and minus. For each integer you choose one from plus and minus as its new symbol. Find out how many ways to assign symbols to make the sum of integers equal to S. All right. So usually when I think about like these like operators and like certain strings, like certain ways, I think about stacks because you can process a lot of that same thing with stacks. But then I'm kind of seeing like this is also a permutation question. And then the way this is set up, it almost looks like a matrix, potentially a matrix problem too. So I'm very interested to see like what steps I should take there. But like just like looking at this input and output, that's my initial intuition. So let's look at this. So another way of saying this too, this might be a potential dynamic programming problem. Find out how many ways to assign symbols to make the sum of the target equal to target S. So like how I'm interpreting this is like maximize the way to assign symbols. So when you hear the words maximize and minimize, you can think of like an optimization problem, which is essentially what dynamic programming is. So is there a way I could find a recursive relation here that would equal the target sum? So then what you would have to do is find out the elements in the array, and then they equal the sum. Okay. So they could all be negative, they could all be positive, they could be a combination of both. So that, yeah, permutation maybe. TP optimization on ways to assign symbols. Looks possible because you only have to return count. Yeah, the more I'm looking at this, the more I do think it's a dynamic programming problem, because you have a matrix. You can actually set like a table to count the ways to minimize, maximize it. There are 5 ways to assign symbols to make the sum. Okay, the length of a given array is positive and will not exceed 20. So this also makes me think about them not wanting to exceed a certain runtime, because if you really don't care about like the length, like that's when you start getting into like recursion being like inoptimal permutations. I remember from like a actual runtime table, when you have factorial runtime, that's like when it starts getting impossible to do. So that like target limit is probably very intentional. So this is like let me know the bounds of the integer too. Okay. So the limit of the array being 20 hints at a very high runtime. Just make sure this is working. Perfect. Okay. And then we're gonna probably have some conditional. So, like high level overview one thinking about is like normal permutations. I know it's not gonna be the best runtime, but I think in brute force instead of swapping, you are swapping. You are alternating between positive and negative values. Okay. So for IDX elam in range lang nums -1, maybe we need like a helper function too. Helper function, so like we can actually like keep track of the count. Ooh, and then we could also do some type of memoization. So like we're not duplicating effort. So we just say, hey, is this element in a hash table? That could help with complexity. Okay, let me think about this. So could we do quadratic times? Could I just like iterate through this? So like, hey, this is positive. This is this is negative. Okay, check if that equals everything. Then this is negative too, and then that check everything. All right. Okay, so yeah, what I'm thinking is you can make nums idx equal nums idx times -1, same thing. So then you get rid of that, right? Just do all here, so self.findWays. And then we just do nums, then s. Okay, so in here we gotta check, hey, okay. So I wonder if you have to add this like memo. So then what you would have to do is just combine So what happens if you like you return a string into -1? Does that let me just make sure. So terminal, I'm just checking Python interpreter to see what happens there. So string -1. Oh, okay, cool. So what I'm thinking about doing is with this memo is just like concatenating everything. So what I mean by that is perm string key equals join and with this you do string char for char out for num. In nums if perm string key not in memo. So again, like what I'm doing is using this hash table to avoid unnecessary computation, because with this permutations you're gonna have to go through so many recursions. So if you already have a permutation or combination that's already been visited, no need to do this computation right here. And then what we do here is memo dot perm string key equals true. So this will only run if it's not already in the hash table. If it is, then I'll just skip that. Okay. And then you want to do a sum too. So if the sum of nums equals s, count equals 0, so count plus 1, and then you just return count, I believe. Okay, let's just make sure this works. So you go through every single element, and then you just join the string. If that string has not already been visited, then you sum the numbers, and then you add by 1. Then you mark it as visited. So this true just means it's been visited. Then you times it, you recall the thing, and then you untimes it, and then you just return the count. All right, let's check this out. Ooh, unexpected indent. Okay. So let me change that. sure all this indentation is correct. Okay, let's try that again. Okay, can I unpack non-iterable? So let's just do this. Oh yeah, because I'm not I'm not using it enumerate, so that's fine. I don't actually use elem, so I can just do this normal range. So I think this is going to be too high of a runtime because this is closer to n factorial. Let's see where I goofed. All right, sum of nums. So for every one of those, to mark that true. So should I check this first and then? No, that makes sense because if it's not in there, you want to run it. So why isn't this count working then? Oh, that's why. Okay, because I'm not including this memo. So I'm not following my own rules. Okay, so I'm still not getting this added. I wonder why. Let's just make sure everything's going right here. So I'm going to print memo and memo, print nums, and then print count. All right. All right, 111 equals true. Oh, so you are adding this, and why is it stopping then? Okay. But it is kind of doing what I want. So like it's adding that hash map. If it's been visited, then remove it. Okay. So the nums is good. Okay. Missing somewhere in this logic. I'm making a mistake. All right. Well, I think I may have been on the right path. Let's just check. Okay. Let's see. Related topics. Dynamic programming depth of search. So I chose the permutations route, and but I was right with kind of my other intuition. So yeah, when I read this question, I thought DP. So find out how many ways. So maximize is an optimization problem, dynamic programming, to assign symbols to make a sum of integers equal to target S. So obviously I got some stuff to review, but thank you for joining me and like watching my thought process. Of course, I hope to get better. I'm going to review these questions and yeah, just try to improve. And yeah, thank you guys, and I'll see you guys next video. Cheers.